Alaikum. Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid, and today we're going to talk about incrementing and decrementing a pointer. So a pointer is a variable that points to another variable by storing the address of that variable, right? Consider a simple example where you're declaring an array of 3 elements, where the first element stores 50, 60, and then 70. And when you type this command and it runs, within the memory you have 3 contiguous elements which have been declared and initialized. They've been initialized to 50, 60, and 70. And if you assume that the first element is present at address 100, then the next one is present at 104, and the third one is at present at 108. Now the reason it's incrementing by 4 because the size of an integer type variable is 4 bytes, right? So, and let's say you see the second command here I'm declaring a pointer array which can point to an integer type variable. So then the memory gives some location to store this variable, which is a pointer, and it can store the address of the variable. So now if I say that this pointer variable has been assigned marks, in other words, this pointer array points to the array marks. When I say something like this pointer array does not point to the entire array. What it really does is points to the first location of the array. So pointer array has been assigned as marks because the address of the first location is 100. This pointer stores the value 0x100. The 0x means that it is a hexadecimal number. Now alternatively, if I would have said that pointer array has been assigned the address of the 0th location of the array marks, it would have pointed to the same location, right? So they both really are the same thing. Here again you see that this pointer is pointing to the same location, and so both these statements really mean the same thing. Now if we were to print this array using the traditional method, what we would do, we would just make an loop and run this loop, and each time we're going to print marks 0, marks 1, and marks 2. Right? And that's what we see here. What we're doing here is we are printing out the address of marks 0 and then the contents, that's 50, and then the address of marks 1 in this case is 104, and then the content which is 60, and then location 108, and then the value which is present at 70. The 0x, again, remember, this is a hexadecimal address. Now if you want to do the same thing using pointers, we would try something different. We would actually initialize the pointer to point to the array. In this case, this is what happens. So pointer array pointing to the array literally means you point to the 0th location of the array, since it's been initialized to 0x100. And then I'm going to increment this all the way till I reach the last location. Notice it's less than equal to the last location, which is the address of marks 2, which is 108. So in the first case, we have printed 100 because that's it's present, 0x100, and the contents of that address, which is 50. In the next instance, it's memory location x0x104, and the contents of 0x104, which is 60, and then last case it's 0x108 and the contents which are 70. Now the principal component here is this incrementing. So let's see what that means. So an integer has the size of 4 bytes. Remember, there's a function size of, whereas a double has size of double is in fact 8 bytes. So when a pointer is made to point an integer type variable, and let's say you initialize it to memory location 100, as was in the previous example, when I increment it, the operating system knows that, listen, you are trying to access an integer type variable next to this location. So because the size of an integer type variable is 4 bytes, the next variable is supposed to be present at 100 plus 4, 104. Whereas when you decrement it, you tell the operating system, listen, right now I am here, but I want to go to a variable present previous to this particular location. So because an integer is the size 4 bytes, you have to decrement 104 minus 4 to go back to 100. Whereas in the other example, because the pointer is pointing to a double variable, and let's say it's the same address 100, because the double is of the size 8 and you want to go to 10 variables ahead of the current variable, you're going to add it with 80, because 8 times 10 is 80. And the 10 variables later is actually present at location 180. Whereas going back means you want to go back one variable. So the previous variable is present 8 bytes before the current location. Hence you're going to decrement it by 8. So let's try running this command, this code in the command prompt or your terminal. So what you're going to go, this is where the codes are present. These are all my codes. And this is the terminal, right? So I'm gonna, this is the code you can see here. It's really, in the first case, I am, printing it using the traditional method of using integer loops. And in the second case, I'm again printing the same, but this time I'm using pointer arrays. So in the first case, I want to make a running code. So for that, I have to compile this. I'm going to write G++. The input is lecture10.cpp and the output I'm going to say lecture 10. Now in Windows you have to write .exe, but you don't have to do that in Linux. When I press enter, notice suddenly this appeared. This wasn't there before. And in order for me to run this, I just write this down and there you go. In the traditional method, the values 50, 60 and 70 are being printed, and even in the pointers, the same values 50, 60 and 70 are being printed. In the first case, this is the address, and notice it's the same address which is shown here. Obviously, I mean the actual address is a little longer in reality, and hence you can see that it's a little longer in size. But notice it's being incremented by 4, right? So remember, always try running the code before you move on to the next slide. So I would strongly recommend that you hit the bell icon. So whenever any new lecture I post, you get to see, you get it in your YouTube feed. Okay, thank you very much. Bye-bye.